Then rule number 5, find the intersection point of root locus branches with an imaginary axis. We can calculate the point at which the root locus branch intersect the imaginary axis and the value of k at that point by using the Routh array method. If all the elements of any row of the Routh array are 0, then the root locus branches intersect the imaginary axis and vice versa. Identify the row in such a way that if we make the first element 0, then the element of the entire row are 0. Find the value of k for this combination. Substitute k value in the auxiliary equation. We will get the intersection point of root locus branch with an imaginary axis. Next, rule number 6. Find breakaway and break-in points. If there exists a real axis root locus branch between two open loop poles, then there will be a breakaway point in between these two open loop poles. If there exists a real axis root locus branch between two open loop zeros, then there will be a break-in point in between these two open loop zeros. Note: breakaway and break-in points exist only on the real axis root locus branches. Follow these steps to find breakaway and break-in points, where k in terms of s from the characteristics equation 1 plus gs into hs is equal to 0. Differentiate k with respect to s and make it equal to 0. Substitute these values of ss in the above equations. The values of ss for which the k value is positive are the breakpoints. Rule number 7. Find the angle of departure and angle of arrival. The angle of departure and angle of arrival can be calculated at complex conjugate open loop poles and complex conjugate open loop zeros respectively. The formula for the angle of departure phi of d is equal to 180 degree minus phi. The formula for the angle of arrival phi a is equal to 180 degree plus phi, where phi is equal to summation of phi p minus summation of phi z. Example: let us now draw the root locus of the control system having open loop transfer functions. Gs hs is equal to k by s whole into s plus 1 whole into s plus 5. Step 1. The given open loop transfer function has 3 poles at s is equal to 0, at s is equal to minus 1, at s is equal to minus 5. It does not have any 0. Therefore, the number of root locus branches is equal to the number of poles of the open loop transfer functions. N minus p is equal to n is equal to p is equal to 3. N is equal to number of poles, p is equal to number of zeros is equal to 3. This one is the root locus branch. This one is another root locus branch. This one is not a root locus branch. Here the number of poles are located at 0, at minus 1 and at minus 5. This is the graph representation drawn between sigma versus j omega. Here two number of root locus branches are there and this one is not the root locus branch. The 3 poles are located or shown in the above figure. The line segment between s is equal to minus 1 and s is equal to 0 is one branch of root locus on real axis, and the other branch of root locus on the real axis is the line segment to the left, that is s is equal to minus 5. Step 2. We will get the values of the centroid and angle of asymptotes by using the given formula. Centroid. The angle of asymptotes are theta is equal to 60 degree, theta is equal to 180 degree, and theta is equal to 300 degree. The centroid and their asymptotes are shown in the following figure. This one is also draw here the curve between sigma versus j omega, and here the different poles are located at x is equal to at 0, and another pole is at -1, and next pole is at -5. The centroid having line is dotted here, dotted lines, that is centroid is equal to -2. Asymptote with 300 degree angle and asymptote with 60 degree angle, and this is the asymptote with 180 degree angle. Step 3. Since two asymptotes have the angle of 60 degree and 30 degree, two root locus branches intersect the imaginary axis by using the Routh array method, and special case to j of root 5, and the another one is minus j of root 5. The root locus branches intersect the imaginary axis at, and there will be one breakaway point on the real axis root locus branch between the poles x is equal to -1 and s is equal to 0. By following the procedure given for the calculation of breakaway point, we will get it as s is equal to -0.473.